Okay, in 15.2, we're going to look at means, medians, which people are probably familiar with, and then percentiles. So first, the average or mean, everyone's pretty used to. You add up all the numbers and divide by how many numbers there are. So if you wanted to write it like a formula, you add up all the digits. There's n of them, so 100, 50, 10, it doesn't matter how many numbers. You divide by how many numbers there were. So one thing that can throw kind of a new idea in this is what if we have one of these frequency tables? So we have to stop and remember what frequency tables mean. When I read this, it means the score 1 is in here once. If I wanted to try to write it back as a list, the score 6 is in here once. The score 7 is in there twice. And then 8 is in there 1, 2, 3, 4, 5, 6 times. Alright, so is there a faster way? Because notice this one's 10, this one's 16. It's starting to get a little tedious to make the list. Is there a faster way? Well, picture if I was going to add up all these numbers. A quicker way than adding 8 together 6 times would be to say, well, what's 6 times 8? If I have 8 6 times, that's literally what multiplication is for. And same thing here, if I have 2 7s, that's the same as 7 times 2 or 14, and then 6 times 1, and this 1 times 1. So you don't have to make this big list. You can actually take how often the number is in there and multiply it by the number itself. So 6 8 means 6 times 8, 9 10s means 9 times 8. So it can be a lot quicker. You can say 1 is in there once, so that's a total of 1, plus 6 is in there once, 7 is in there twice, so that'll add 14 to our total. 8 is in there 6 times, so that'll add 6 times 8 or 48 to our total. 9 is in there 10 times, 10 is in there 16 times. That can be way quicker. You're grouping them together using multiplication. And so if I do that and add them all up, for this specific example, I get 814 as my total. So that'd be the same thing as if I wrote out the whole list and added up all those numbers. All right, well, how many numbers are there? Sometimes they tell you right in it. If they don't, if you add up all the frequencies, then that's telling you how many times each number appears. That should give you the total number of numbers. And so if I add them up here, this was for 75 test scores. So if I added up all the frequencies, that should add up to 75. And so this is a total, after I do all that multiplying, of 814, right, times how many times it's in there. And there's 75 different numbers. So the average is the total of 814 divided by 75, so 10.85 points. And so if you want something in general, you do the value times how often it's in there, and then add those all up and divide by how many numbers there were. One thing about averages is that they're really susceptible to outliers. And so here's an example where they talk about philosophy majors from a certain school have an average salary of $76,400 a year, which sounds like a lot, especially maybe for philosophy, or a lot in general. And so where did they come out to this average? Well, one thing they didn't mention is that one of these students in this average group doesn't work in philosophy or doesn't work using their major specifically. They apparently are in the NBA and make $3.5 million a year. So we just want to see how much that actually sways the average. So apparently this was 75 philosophy majors. So thinking of kind of a frequency table sort of idea, I don't have to know what each of those other 74 people make. I can still figure out that if the average was 76,000 for 75 people, it'd be the same as if everybody made the exact same amount. And so I can do 75 times 76,400 to figure out what the total was before they took the average. Because think, to get to that point, they took the total of all the salaries, which apparently is this, and they divided by the number of people that were in that group. That's where 76,400 came from. So I'm kind of reversing that idea by, if I multiply both sides by 75, so 75 people had this average, means this is the total. And so here, now that I know the total is this 5.7 million, but I know this one person accounts for 3.5 million of that. So if I take that one person out, let's say I subtract out his salary, then I'm left with this for the other 74 people. And so if I want the average for the other 74, here's their total and divide by 74. And so the average for everyone else is actually only 30,000. So one person was able to make the average look like it was over 2 times as much as it actually was. Okay, the percentile, the biggest thing to remember about this is when you start calculating the numbers, it's how far through the list you are. So say if you score the 90th percentile on a test, it means that you did better than 90% of other students on that same test. So you were in the top 10%, or you're the split between the bottom 90 and the top 10. So it's always saying how many you did better than. All right, first thing, your data has to be in order for this to make sense. So if we put our list in order, and then we're going to do the locator. So let's say if I have 100 numbers, then the 80th number is 80% of the way through the list, or the 55th number in the list is 55% of the way through the list. So if it's a bigger or smaller list, we want to know what's 55 or 80%, what is that percent of how long our list is. So first thing you do is take the percentile you want. So as a percent, that's why they put this divided by 100. So like 80%, you put 0.80. And you multiply by the length of your list. So is it 20 numbers? Is it 100 numbers? Is it 1,000 numbers? How many different scores or values are in your list? And what that's telling you isn't the number that represents that percentile. It's telling you the locator. How many numbers into the list do you have to go to be that far through it? And so then they have this rounding rule, which is not universal, I'll admit this one. So you have to be careful if you just go to like a percentile calculator or sometimes even Excel. If it's not using this exact same rule as the book, then it'll give you a slightly different answer. There's different ways to round these, but this is a nice, quick, simple method. If your locator is a whole number, you have to go a little bit bigger than that. So say if your locator ends up being 12, that means go to the 12th number on the list. Then you won't actually go to the 12th number, you'll go to what we consider 12.5, means halfway between the 12th and the 13th number. So you'll have to average them together to figure out what's halfway in between. If you land on something that's not a whole number, and you always round up, it doesn't matter about the normal rounding rules, just if you're not on a whole number, you go up. So let's say you got a locator of 12.1. Then you'd automatically go to the 13th number. So 12.1 doesn't need to be more than 0.5. It's going to round up no matter what. All right, so let's try one. So this one has a program in which GPA is in the top 20th percentile. Now be careful, that means that you're at the 80th percentile. So top 20 is better than 80% of people. Get a $5,000 scholarship, and then athletes with GPAs in the top 45th, so you got to do better than 55% of people, get a $2,000 scholarship. All right, so first, here's all the GPAs. It looks like there's 15 players that you're competing against kind of for the scholarship. And so then we have to put it in order. So we can say, okay, here's the lowest one and here's the highest one. So if we want to know who's in the top 20%, what we're really looking for is the 80th percentile. So I want to know, okay, if I have 15 numbers, what number is 80% of the way through a list of 15 numbers? So 80% times 15 gives me 12. So this is my locator. But then picture, just like on our rules, this is a whole number. So I automatically want to round up. So I'm going to take digit 12.5. Now notice there is no 12.5. We're saying halfway between 12 and 13. So let's say if this is the 15th one, I'm just going to count backwards because there's 15 numbers here. It's probably easier. So this is 15, 14, 13. So I want the value that's halfway between this and this. So if I average, or if I look and say they're 0.06 apart, so it looks like 3.85 is halfway between 3.82 and 3.88. So this is the thing to be careful about when you do these. This is your top 20th or your 80th percentile. This stuff you calculate is just telling you go to the 12th or the 12.5 number. It's not telling you what the value actually is. Okay, and then for the other one, we want a 55th percentile. And so here's the one we just did, the 3.85. And so to get a 55th percentile, and so look, if we look who's above it, who actually gets the scholarship, if 3.85 is our cutoff for the top 20%, if we go to this list, then this person, and this person are all in the top 20%. So for the 55th, what number is 55% of the way through a list of 15 numbers is 8.25. Since that one didn't land on a whole number, we always round up. So we want the 9th number in the list. So if I go back to my list, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th number in the list is 3.67. So that means anybody above 3.67 is in the top 45%, so they get the $2,000 scholarship. So the biggest thing is the locator means like the 12th or the 9th number in the list. It doesn't mean that that number is your actual data point. And then median, same idea, it's just the 50th percentile, so what's in the middle. And you already, this rule about rounding up or down happens automatically anyways. So picture if you have an even amount of numbers, let's say 4 numbers, then your median will be halfway in between 2 and 3. If you have an odd number of numbers, so let's say 5, then your median falls right on a number. So, and another two that become important, they use them often enough they give them their own names, is Q1 means the 25th percentile, and Q3 means the 75th percentile. So here's one for home sales. So let's say we put them in order. And here they just took the zeros off. Oops, they took the zeros off them because they're all by thousands. So 267,000, they just wrote as 267. Okay, so if I want the median, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So halfway through this list, would be this, because there's 5 numbers on this side and 5 numbers on this side. So that gives me a median of 252. And then if I want the 25th percentile, I'll say, well, what's 0.25 times 11? And we'll see, I think they're going to do some of this work on the next slide, so I won't double it up. So 0.25 times 11 is 2.75, so I round up and take the third number on the list. If I want to go 75% of the way through, what's 75% of the way through 11 numbers is 8.25. Since that didn't land on a whole number, I also round up. So Q1 is at the 3rd, and this one's at the 9th. And if you look at the list, you can kind of see the symmetry to it. Like if this number here is the median, and then they said the 3rd number is 25% of the way through the list, so Q1, and the 9th number is 75% of the way through the list. You can kind of see how that works out symmetrically. It's like this is the first 25%, this is the next 25% of the list, this is the next 25%, this is 25, 50%, 75, and this is the top 25%. And then once again, if you ever have to do one of these with a frequency table, be careful that you don't just go, oh, this number's in the middle. This is a bigger list. This is a list of 75 numbers. You have to keep track of the fact that this is the first number, second one. This one's actually listed 6 times here. And so you can draw out the whole list, or you can count how far into it you want to be. So let's say if I have 75 numbers, find out which one they're doing here. Yeah, so if I have 75 numbers, if I want Q1, we'll focus on, for instance. If I go 25% of the way through the list, that's 18.75. So if I round up, I want the 19th number in the list. So if I go to my list, I have to be careful. If I just go like this, I'm run out of numbers. 19th means there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. this would be 20. So somewhere in between when you're at the 9th